So the question we're trying to solve today is, a parallelogram has vertices A, -1, 3, 5, B, 2, 1, 3, C, -1, 1, 4, and D, of which we don't know the values of yet. So find the coordinates of D, the side lengths of a parallelogram ABCD using its exact value, and determine the area of parallelogram ABCD, correcting the value to the nearest tenth. Oh, forgot the bracket. So let's see, how should we start this off? So to begin this question, let's first make our lives easier by drawing a diagram of the parallelogram. So we know a parallelogram looks like something like this, you know? Sorry for my poor drawing, but yeah, something like that, where this side and this side should be parallel to each other, and the top and bottom should also be parallel to each other. And since we're drawing parallelogram ABCD, we need to label each of the vertices with ABCD, and we're gonna have to do this in a clockwise fashion. So we'll label this A, B, C, and D. I mean, we didn't really have to do it clockwise, but the point is that they need to be in order when we label them. You could have done it counterclockwise too, like A, B, C, D, but today we're gonna stick with A, B, C, D in this direction. And oh yeah, let's just write the points out again to make our lives easier also. So A is -1, 3, 5. B is 2, 1, 3. And we know that C is, the bracket kind of looks like, I guess we'll have to deal with that. -1, 1, 4, and then we don't know what D is, so let's just use some variables to replace the values of D for now. So let's just do X, Y, and Z for simplicity's sake. So yeah, first step, let's try to find the coordinates of D. So first, let's make a let statement. Let D, sorry, writing is a bit hard. Let D equal, or let D be bracket vertices X, Y, and Z, as we stated earlier. And now to find D, so what do we know? So what we do know about this parallelogram is that the side AB should be parallel to the side DC. And so we can basically say that the vector of A to B should be equal to the vector of D to C, since these sides are supposed to be parallel. So first let's write that. So vector AB should be equal to the vector of DC. Now that we have that, let's find the vector AB and the vector DC. So how do we find vector AB? Well, from what we learned before, we know that to find the combined vector of two vectors, we need to take the x value of the second term, subtract the x value of the first term, and then the y value of the second term, subtract the y value of the first term, and then etc., etc. So let's do that. So for vector AB, we might need a bit more space. Sorry, let me grab my eraser. And we're back. So to find the vector of AB, as we mentioned earlier, we need to take the x value of the second vector, so in case the case here is B. So we take the 2, and we subtract the x value of the first vector, which is A, and we know that is -1. So it will be 2 minus -1. Now repeat that for the y value. So the y value of B, 1, subtract the y value of A, which is 3. And then the z value of B, which is 3, minus the z value of A, which is 5. So this is what we have so far for vector AB. And now let's do the same thing for vector DC. We'll need a pretty big bracket for this one as well. All right, repeating the same steps we did earlier, we need to take the x value of the second vector, subtract the x value of the first vector, and then doing the same thing with y and z. So the x value of C, our second vector, which is -1, we need to subtract to that the x value of D, which since we don't know what it is, we just have a placeholder for now, which is just x. So we subtract x. Now the y value of C, 1, subtract the y value of D, which once again we have a placeholder because that's what we're trying to find, so let's just do -y. And lastly, the z value of C, which we know is 4, and then also subtract that by the z value of D, which, once again, our placeholder Z. So this is what we have so far, and now we can just simplify whatever is here, since you can't really simplify anything here. So this size stays as is for now. And then we have -2. Oh, the bracket is too big. Give me a second. So we have -2 minus -1. That'll just be 2 plus 1, which will give us 3. 1 minus 3, which is -2. And 3 minus 5, which is also -2. So this is what we have so far. And basically, remember, we're trying to solve for the values of D, which is x, y, and z. And so since this is an equation, essentially what we want to do is set the x value of this to equal to this. So the x value of the first vector AB, set that equal to the x value of vector DC. Same thing for the y values and the z values. And by doing that, we can solve for x, y, and z. So let's do that. So we have 3 equals this, which is -1 minus x, and then we have the y, so -2. That should be set equal to the y value over here, which is 1 minus y. And then we have our z, which is also -2. And we should set that equal to the z value over here, which is 4 minus z. And now we just want to solve for each of them. So here we want to solve for x. Let's move the 1 over. By moving the 1 over here we'll have 4 equals -x. And that just makes x equal to -4. And over here, we want to bring the 1 over here to the 1 over here with the -2, and that will give us 3 equals -y, which means y is equal to -3. Or sorry, no. Y should equal, I made a small mistake. So by moving the 1 to the other side with -2, it's not 3, it's actually -3. So we have -3 equals -y, and that just turns into y equals 3. And over here, we have 2 equals 4 minus z. If we bring the z over, if we bring the 4 over, we would have 6, and then equals to, -6. Once again, I made the same mistake. But -6 equals -z, and then z would equal to just 6. So there, we found the coordinates of D, which is, so D has the coordinates of -4, 3, and 6. So there, that's our first step done. Now let's move on to the second part of the question. We need to find the side length of A, B, C, D, and we need to use the exact value. So let's think, what do we know about the side length of this parallelogram? Well, we do know that since these two sides are parallel, this should mean that these two sides should have the same side length. And same thing with the top and bottom. They're also parallel, which means they should have the same side length. So let's make some statements here. So for side lengths, so basically the length from A to B should equal the length from D to C, and same thing vice versa. So B to A should also equal the same as C to D, or D to C, as, you know, it's just length. The direction shouldn't really matter. And when we want to find the length of A to B, we are essentially finding the magnitude of vector AB. So we can write that the magnitude of vector AB should equal to the magnitude of vector DC. And the same should be true when it's the opposite. So I guess the magnitude of vector BA should also equal to the magnitude of vector CD. And that's for these two sides. And then we also have the top and bottom. So what we know about the top is that the magnitude of BC should equal to the magnitude of AD. So let's write that. Magnitude of BC should equal to magnitude of AD. And the same thing is true when it's the opposite. So the magnitude of CB should also equal to the magnitude of DA. CB should equal to the magnitude of DA. So, you know, I don't think it's necessary for us to solve each one of these. Let's solve for this one. So, and I guess this one, as the other two are just like the same thing, but in reverse. So first, let's solve for the magnitude of AB. So first we need to find what vector AB is. Vector AB, as we actually already found earlier, here it is. The A doesn't really look right. Okay, so vector of AB, we found that it is equal to 3, -2, and -2. And now we want the magnitude, and to find the magnitude, we just want to take each of the terms here and here, x, y, z. We want to square all of them and then add them all up, and then square root the result we get. So we'll have 3 squared plus -2 squared plus -2 squared. And that will give us the square root of, this will turn to 9, 9 plus 4, that'll give us 13, and then plus another 4, that'll give us 17. So the answer of the magnitude of vector AB is root 17. So this entire side length here is root 17. And since we know that, just to confirm, let's also find the side length of this side, since, as we stated here earlier, the magnitude of AB should equal the magnitude of DC. So DC. So let's find vector DC. So we actually have not found vector DC yet, so let's do that. As I mentioned earlier, to find the combined vector of two vectors, we take the x value of the second term, subtract the x value of the first term, and then so on and so forth with the y and z values. So the x value of C we know is -1. -1, subtract the x value of D, which we found earlier, which is -4. So that'll be -1, subtract -4. And then we have the y value of C, which is 1. Subtract the y value of D, which is 3. And then we have the z value of C, which is 4. subtract the z value of d, which we found was 6. So that means for vector dc, we have -1 minus -4, that will give us +3. And then 1 minus 3, that is -2. And 4 minus 6, that's also -2. So as we can see here, the vector dc is actually the same as vector ab. So when we find the magnitude of dc, it should equal the magnitude of ab. But let's just do it just to confirm. So magnitude of dc should equal the square root of the x term squared, so 3 squared, plus the y value squared, which is -2 squared, plus -2 squared again for the z value. And so 3 squared, that's 9, plus -2 squared, that's 4, so we have 13, plus -2 squared again, which is 4, 13 plus 4, we have, once again, root 17. So here, we prove that this statement is true. The magnitude of AB, which is this side, they're the same length as the magnitude of DC, which is this side. Now let's find the other two sides, AD and BC. So we're trying to solve this. So we have the vector of BC, and we have not found that yet, so let's do that. The vector of BC, repeating what we did earlier, we'll need the x value of the second term minus the x value of the first term, and then so on and so forth with the y values. So x value of C, that is -1, minus the x value of B, which is -2. And then the y value of C, which is 1, minus the y value of B, which is also 1. And then the z value of C, which is 4. And the z value of B, which is 3. So 4 minus 3. And that will give us, so the vector of BC would be -1 minus -2, which is -3, comma 1 minus 1, which is 0, and 4 minus 3, which is also 1. So this is vector BC. And now we need to find its magnitude. So the magnitude of vector BC, that would be whole thing square rooted, and then we need to square the x value, so -3 squared plus 0 squared plus 1 squared. And when we do that, -3 squared, that gives us 9, plus 0, that's just 9 again, and then plus 1, 9 plus 1 is 10. So the magnitude of vector BC should be root 10. So this length here should be root 10, which means that this length here should also be root 10. So let's confirm that. So now we need to find the vector AD. So vector AD, let's repeat the same steps we did earlier. X value of D, we know is -4. Subtract the x value of A, which is -1. Subtract -1, so. And then we need to find, we need the y value of D, which is 3. Subtract the y value of A, which we know is also 3. Lastly, we need the z value of D, which we found here, 6. Subtract the z value of A, which we have here is 5. So now to solve for this, -4 minus -1, that is -3. 3 minus 3 is 0, and 6 minus 5 is 1. So that here we have the coordinates of vector AD. And, it's the same as our vector BC, which means once you find the magnitude of this, it should equal this, and that will prove our statement here. So let's find the magnitude of AD. Finding the magnitude of AD, square root everything. -3 squared plus 0 squared plus 1 squared. And that's the same thing we had above, so we know the answer is also root 10. So yeah, so that means the side length here, vector BC, it's also root 10, and the side length here, vector AD, or the magnitude of vector AD, is also root 10. So for our therefore statement, therefore, the side lengths of A, B, C, D is